Hello everyone, this is Jeff Wilkerson, Professor of Physics at Luther College. What we're going to talk about today is setting up a crude microscope in the general physics laboratory and trying to measure the magnification of that microscope. So this is what we're going to do here is we're going to start the microscope. Let's start there. The microscope, as hopefully you know, for my students who are going to be doing this as part of this ongoing experiment, I definitely recommend that you go back and you refer to your textbook, section 19.4, the microscope, and read all the way through it about how to set that up and pay particular attention to the magnification on the top of page 672 of your textbook to talk about the magnification. Textbook is College Physics by Knight, Jones, and Field, by the way. And so they pay close attention to how to set up the microscope and how to measure the magnification, how to predict what the magnification of the microscope is going to be. And so what we're going to do here is we're going to set this up now with two lenses, an object, and then your eye up against the lens to try to look at that object. Here's how we're going to go about doing it. We're going to start with one lens here, and then the object out here, which is just outside the focal length someplace of the lens. So you've got it outside here. It's going to make a real image on this screen. So we're going to adjust this screen until we get a good crisp real image from that lens. Remember, the goal of our microscope is to make an image with the first lens that we're going to use as the object of the second lens, and then get a magnification from that second lens that way. So what we want to do is make a good crisp image on the screen with our first lens, and then if we plunk the second lens in behind the screen over here, see what we've done here now is we've put the second lens in over here behind the screen. We can adjust this lens. We want to get our eye up good and close to it, and we can adjust this lens until we get a good crisp focus on the back of that screen. And if we've got a good crisp focus on the back of that screen, then the screen thickness isn't very much. That means we're going to be focused on this image when it comes out. We just pop the screen out, and we should be able to see an enlarged image of the object that we have down there. So we will probably need to adjust this a little bit because the screen thickness wasn't infinitely thin. And so we probably need to move this forward just a little bit, adjust it till we get a very, very best image that we can get. Now, what we're going to try to do with that image is we're going to try to measure the image's magnification. So we want to figure out how big that image is relative to how big the object is. So we do that. Here's our object. Our object has a width. These arrows here have widths to them. You can measure what those widths are, or you can measure you can use the grid that's on there to try to measure the lengths of the arrows. So you can measure some property of those arrows, and then what's a real challenge? It's going to be there's a hard measurement to make, but we're going to do what we always do, and that is to say, when we're trying to make a hard measurement, we're just going to repeat the heck out of it, and hopefully we can make up for some of that uncertainty in that measurement by just repeating and repeating and repeating. We're not going to be able to fix inaccuracies. We're not going to be able to fix biases that way, but we will be able to reduce the uncertainty due to the lack of precision. So sigma over the square root of n, the standard error, if we can make a lot of measurements. So we just want to adjust and adjust and adjust, try tweaking different distances of this and different distances out here. Just keep repeating this until you get that measurement. And what we do is we're going to take a ruler, and I had a ruler here, but there it is. You're going to take a ruler here, and you're going to hold it up over the image that you see, and you're going to get your thumbnails maybe. You can use your own technique, but that's what I would do, is to take my thumbnails and align them with the image that I see, the edges of the image, and then I can measure how big the image is. You're going to need help. You're going to have to work as a team to do this. And I can measure how big the image is in millimeters, see if I can get to the nearest tenth of a millimeter like that. Maybe, I don't know, maybe we'll try using the digital calipers. I just thought of that. We take the digital calipers and you can just open them up and close them up until the teeth of the calipers align with the edges of that bright arrow, that bright cross side right there. And then you can read what the caliper says the separation is, the size is of the width of that arrow. Then you measure the width on here, and boom, your magnification is going to be image size divided by object size. So you measure the image size. Again, this is a really hard thing to do. I'm going to recommend that you have multiple people. You have both people in your group. If you got two people in the group, making this measurement, and you keep trying it in different ways and doing different things. But then you're going to compare that to the expected value for the magnification, as we talked about in your textbook there just a moment ago. So go find the expected value. The way I do that, you're free to do that. I might do that by taking the difference, one of those minus the other one of those, and making a histogram of those values to see if the mean of that histogram is consistent with 0, or are you always overestimating or underestimating, and how wide is that histogram? How good a job are you doing measuring that magnification relative to the predicted magnification? So that's what we're going to do. We're going to set up a microscope. It should be fun. Again, this is a good experiment. We got 3 weeks. We're going to have to work pretty hard to get enough data to be able to measure what we want to measure. But I like what we're doing, and I think we'll be able to do this pretty well. So good luck with it, everybody, and we will see you in lab.